All right, if you're a data operator or an automation dev dealing with scheduled Dagster jobs, you already know the exact pain we're tackling in this explainer today. Everything is humming along smoothly, right? And then boom, your pipeline hits a Captcha-protected form, portal, or login. And since scheduled data jobs run completely unattended, your pipeline can't just sit there twiddling its thumbs waiting for a human to log in and solve it. So today, we are going to walk through the exact production checklist you need to safely and reliably call CaptchaAI from a Dagster asset. We're going to take your setup from a fragile duct tape script into a rock-solid, production-ready integration.
So here's our playbook today. We'll be hitting 5 key areas: the production reality, authorized scope and ownership, submission and polling loops, session context and retries, and finally, measuring real success.
Okay, part 1, the production reality. We really need to move beyond the happy path here.
You know the drill. Calling CaptchaAI from a Dagster asset looks deceptively easy when you're just messing around in a local Jupyter notebook. You can usually hack it together in like 5 minutes. But man, the visceral panic of a 3 a.m. PagerDuty alert, that tells a totally different story. Unintended production runs are brutal. They have to survive deploy windows, random network hiccups, and completely unannounced changes on the live page, and they have to do it all without any human handholding. To actually survive in that production environment, we must absolutely avoid creating what we call a black box asset. Since these scheduled data jobs run without a human watching them, a black box asset is literally your worst nightmare. It's a pipeline step that fails completely silently out there in the external workflow ether. It has no clear inputs, zero controlled polling, and the error logs are just totally useless. We need predictable SLAs, not a mysterious black box that breaks our pipeline.
Moving right along to part 2, authorized scope and ownership, it's time to set some strict boundaries.
Before you write a single line of automation code, listen up. This is absolutely crucial. These workflows must strictly be used in owned, client-authorized, or contractually permitted environments. CaptchaAI is engineered for predictable data collection, internal ops, or QA testing. It is definitely not a tool for circumventing protections on sites where you have zero agreement or authorization. Always confirm your workflow is permitted first.
So once you have that authorization, what does your Dagster asset actually own? Well, a well-built asset shouldn't leave you guessing. It needs to easily answer 3 questions. What exactly was expected to be materialized? What external step was actually required? And most importantly, where specifically did the workflow succeed or fail? Your asset has to emit crystal clear metadata about latency, retries, and the exact reasons for failure. When it comes to the data you're pulling in, seriously, less is more. Most failures actually start right here, with bad request data. You want to strictly capture only the exact inputs the CaptchaAI solver needs for that specific Captcha family. We're talking the site key, the page URL, the action value, and the Captcha method. That's it. Do not store unnecessary page data. Hanging on to extra data just creates these wild goose chases and false debugging paths that will totally frustrate your team later. All right, part 3, submission and polling loops. This right here is the mechanical core of the whole interaction. Okay, this is a trap so many integrations fall into. A successful HTTP request, meaning you got a nice 200 OK status over the network, does not mean the solver actually accepted your Captcha task. You got transport success, sure, but task acceptance is a completely different hurdle. You have to treat the API status as a critical decision point. If that solver returns anything other than a success status, you need to log that full response safely, flag your monitoring, and stop the job immediately with a clear reason. To handle this smoothly, you need a tightly controlled polling pattern. Overpolling just spams the API and adds noise, while underpolling slows your whole workflow down. So here's the golden rule of thumb. Submit your task, then wait a solid 15 seconds before your very first poll. After that, poll every 5 seconds. But, and this is a big but, set a hard maximum cap of 120 seconds per task. If you don't have it by then, exit with a failure. You absolutely cannot let hanging polling loops run forever. They block your Dagger schedules, they delay everything downstream, and they just waste compute resources. Part 4, session context and retries. Let's dig into why your perfectly good tokens might still be getting rejected. Imagine this. You get a valid token, you plug it in, and the downstream workflow still fails. Why? Well, ask yourself this one pivotal question. Is the solved Captcha token being applied in the exact same logical session?
This is literally the #1 debugging scenario for integration engineers.
You see, a solved token is almost always intrinsically tied to the exact session that originally triggered the challenge. It's like handing off a baton in a relay race. To preserve that session context, you have to apply the solve using the exact same browser context, the exact same HTTP client state, the identical cookie jar, and the exact same user agent and IP context. If you take that shiny new token and hand it off to a completely different HTTP client or fresh cookie jar, the downstream verification is going to look at it, realize the context doesn't match, and reject it outright. Now, what if things just break before you even get a token? Well, you need a strict retry budget. Infinite retries are a terrible idea. They just hide fundamentally broken setups and burn through your account balance. The smart play is an exponential backoff that caps out at a max budget, let's say 3 attempts. So attempt 1 fails, you back off. Attempt 2, back off longer. After that 3rd attempt hits the max budget, you trigger a terminal error log. This gives you resilience against temporary network blips without masking real persistent defects. But here's the thing. Some errors are just not retryable. Seriously, if you have a bad API key, missing parameters, a malformed URL, a zero balance, or you're just using the wrong Captcha method entirely, do not retry. Hammering the API 50 times isn't going to magically fix your API key. It just burns your balance and completely delays the failure alerts that your DevOps team desperately needs to see.
Finally, part 5, measuring real success. How do we definitively prove our integration is actually healthy out there in the wild?
We really need to separate 2 concepts here that get tangled up all the time: solver success versus asset success. Did the CaptchaAI API return a token? Great, that's solver success. But did the Dagster pipeline actually successfully materialize the downstream data you needed? That is asset success. Getting a token is a milestone, for sure, but a solved task is definitely not the same thing as a successful pipeline.
If you can't measure it, you can't defend it, right? These KPIs are your best friends. To put this in perspective, your first solve latency should be sitting comfortably under 25 seconds for token captchas and under 8 seconds for image ones. If you hit that, it tells you the system is healthy and you aren't stuck waiting on retries. Your solver success rate should ideally be 95% or higher per family, which proves your inputs are solid. But here is the real kicker. Your end-to-end acceptance rate absolutely must also be 95% or higher post-token. If your solver is returning tokens all day, but your end-to-end acceptance is tanking, you've almost certainly got that session mismatch issue we talked about a minute ago.
And when things do go sideways, and they will, your operators need precision. Vague logs like Captcha failed or asset error are worse than useless. You've got to structure your logs with essential handoff metadata. Give them the exact Dagster asset name, the specific run ID, the Captcha method, the attempt count, exactly how long it was polling, and the response category. That is how you enable rapid, targeted troubleshooting instead of endless wild guesses. In fact, if you log correctly, you can spot the fix for like 90% of support tickets instantly. Seeing an error wrong user key, you probably just copied it with some stray whitespace. The fix is to store it as a clean CI secret. Hitting an error zero balance? Well, top up the account and set up a basic dashboard alert so it doesn't happen again. And if your token is getting rejected post-solve, maintain that HTTP context we hammered on earlier. Actionable logs point you straight to actionable fixes.
I want to leave you with this final drop-the-mic thought from the source material. The real success metric is not token received. The real metric is whether the asset materialized the expected results. If you follow this playbook, if you capture exact inputs, lock down your polling loops, fiercely protect your session state, and measure your actual asset success, your Dagster jobs are going to run quietly and reliably. But honestly, take a hard look at your own pipelines today. If an external API failed silently right now, how long would it really take your team to notice? Thanks for joining this explainer, and we'll catch you on the next one.